Good morning, children. How are you? Yes, I am also fine. So I hope you all are studying nicely at your home. You are safe also. You are coming out with your mask and all these gloves and sanitizers. Okay, so be safe. Okay, from this disease because we have to give the board examination. So for that we have to be fit and fine. Okay, so for that keep take care of yourself. And now we are going to discuss a triangle. Many things we have learned, how it can be put, angle similarity we have done, angle side, that side angle side properties we have done, side we have done. Now we will find what is the relation between the area of a similar triangle and its other parts like altitudes, like medians and all these things. Okay, so let us see how it can be. This is how that this is the similarity. What is called similarity means corresponding angles are congruent and their corresponding sides are proportional. No need to discuss this again and again because we are now, you all are now mastered in this all, I know that. So here is that one last time we are going to recall these properties here. These are the three rules that will prove that triangle is similar. And actually today what we are going to discuss is that one here, this property is here, that if two triangles are similar, then the ratio of the area of both triangle is proportional to the square of the ratio of their corresponding sides. Okay, that means the ratio of area of two similar triangles is proportional to the squares of the corresponding sides of both the triangle. So this property we are going to discuss here. Actually this, through the figure I have tried to explain this. These two triangles are here. So area is A1 and A2. So their ratio I have taken. So that will be equal to L1 square and L2 square. Means if I am taking L1, I have to take this side L2 only. So this is one main property of similar triangles also. On this I have tried to make one video. I hope this will help you there. So let us see that video. Here is that video only. One thing. Let me explain this first here. It is saying that the area of an equilateral triangle described on one side of a square, area of an equilateral triangle described on one side of a square is equal to half the area of an equilateral triangle described on one side of its diagonal. Okay, so let us see what is the figure of this question. So the figure is here. Now this is the complete figure I have drawn here only. See, this is the complete figure. Okay, this is one side here. On that side I have drawn this equilateral triangle. This is the diagonal here. On the diagonal this is also an equilateral triangle, means all three sides are equal, and we have to find the relation between the areas of these two triangles. Okay, so let us see how we have done this. So first of all, it's important to know the sides of the triangle. What is the sides of these triangles are? Okay, for ABCD square means all four sides are equal, so its sides we can take, okay, as A. Okay, that is the side of A unit. Okay, now on that sides and diagonals we have drawn two equilateral triangle. This is the hint only. The equilateral means all three sides are equal. So triangle ADP is an equilateral triangle and its all sides are A unit only. Okay, ADP is an equilateral triangle, then its all sides are A only. Why? Because it is based on one side of the square, and the square of the side is A. Second is triangle BDQ. This is also an equilateral triangle, but on the diagonal, but made on the diagonal here. So first of all, we'll try to find out what are the side, and what is we have to prove here. So what we have to prove? We have to prove that area of ADP and area of BDQ. Okay, so we have to make it 1 by 2, not 2 by 1. By mistake I have written here. Actually it is because that question was erased there, so it is 1 by 2 basically. Okay, it is 1 by 2. When I read the questions, I found the mistake here. So now we have to prove this. We can do it nicely here. See how ADP is there, ADP and BDC. First of all, find the measurement of the sides. What is the measurement of the side here? Okay, so one thing is remembering that now the ratio of the that area of the center triangle is proportional to the square of their sides. Very good. That one you have to remember only, and then it will be solved. Okay, so area of triangle ADP is equal to root 3 by 4 into side square. Side is A only. Side is A only. Now see why it is A only, because this triangle here is made on this side and the unit of this side is A. So by the formula it is root 3 by 4 into A square. This we have found. Now this area we have found. Now we have to find area of BDQ also. We have to find the area of BDQ also. So first of all, it is important that what is the side, what is the length of the side of that BDQ. Okay, now this triangle we have to find. I think you are knowing what sir is going to do here, because mensuration concept we are going to use here in this. Okay, so area of triangle BDQ is root 3 by 4 into that BD square, and BD is the diagonal of the square. So diagonal of a square we can easily find. We have a formula also. So that is BD is equal to root 2 into side. Diagonal of a square is the same formula, root 2 into side, that is root 2A. So we found BD. So I hope now you are jumping there that this question has been solved only. Yes, this question has just now solved when you have found the BD only. So BD is equal to root 2 into A. So this BD will go in that formula there. Okay, so that area of triangle BDQ will become root 3 by 4 into root 2A whole square. Okay, so root 3 by 4 into 2A square. Okay, now we have found area of triangle BDQ also. Now we have to just find the ratio of these two triangles, and we have to prove them 1 by 2. Okay, so now area of triangle ADP by area of triangle BDQ, so that is equal to root 3 by 4 into A square. Upside, downside is root 3 by 4 into 2A square. Okay, A square cancel, and root 3 by 4 and root 3 by 4 is also cancel. What is remaining here then? 1 by 2 only. 1 by 2. So we have proved also whatever they have asked. We have just now proved also. See here what we used here in this question. First we used the mensuration part, and we found the area of this triangle and area of this triangle. By using that mensuration only, we have found the length of this line BD, and then we use the similarity. So many applications are there in this question, mensuration plus similarity. So you cannot say if the question is from similarity, so I have to use only similarity. other topics I don't need to use here. No. These are called application based questions. 1 2 3 4 type of topics will be used in one single question. So that type of questions we have to practice. We have to learn also what I have used here. Okay, so in the next class we'll learn something new. Till then, all of you take care. Thank you, class. Thank you very much.